Hello students, welcome back to Learning Science Q&A. Today we are here with part 4 lecture of Atom and Molecule. Chapter Structure of the Atom we have already taken. These are chapters from class 9th NCERT. So let's get started. During our last video we have already seen about the Dalton's theory or the Dalton's proposal about the atomic structure. He said that atom being the very tiny particle, indivisible, capable of taking part in chemical reaction, two of Dalton's postulates are known as the law of conservation of mass and law of constant proportion. So these postulates are atom are indivisible particle which cannot be created or destroyed in a chemical reaction and they are participating in the chemical reaction. Also, law of constant proportion says atoms combine in a ratio of small whole number to form compound and the relative number and the kind of atoms that are taking part in a chemical reaction or that are forming a compound are always constant. They do not change based on the source of compound or the method which is used to form that compound. So let's see the first law, that is law of conservation of mass. It states that mass cannot be created nor it can be destroyed. However, it can be transformed from one form to another. Based on the conservation of law of mass of reactant must be same as the mass of the product. That means how we are going to apply this during our examination if we are provided with some kind of question. Mass of reactant must be same as the mass of product. That means if we have given one equation, say methane reacting with oxygen to produce carbon dioxide and water. 16 gram of methane interacting with or reacting with 64 gram of oxygen to produce 44 gram of carbon dioxide and 36 gram of water. So if we want to apply law of conservation of mass, then we would say that mass of the reactant, which is 80 gram, must be equal to the mass of product, which is 80 gram here also. So this equation is feasible if we talk about the law of conservation of mass. Many times it may happen that the mass are not equal at both the side, and at that time we'll say this is not true. This equation doesn't hold true for the law of conservation of mass. Let's see some more example. In a reaction, 5.3 gram of sodium carbonate reacts with 6 gram of ethanoic acid. So these are the reactant side. Products were 2.2 gram of carbon dioxide, 0.9 gram of water and 8.2 gram of sodium ethanoate. We need to show whether these observations are in agreement with the law of conservation of mass. What we need to do? We need to add total grams in the reactant side, which are 5.3 gram and 6 gram, and to check whether they are equal to the grams given at the product side. Right? So let's see it. We have the chemical reaction between sodium carbonate and ethanoic acid to produce sodium ethanoate, carbon dioxide and water. So mass of reactants are 5.3 gram plus 6 gram. Mass of product is 2.2 gram, 8.2 gram and 0.9 gram. This ratio mark must be ignored. These are decimal. So these are 5.3, 8.2, 2.2. So the mass at the reactant side is 11.3, which is equal to the mass at the product side. So we can say yes, these observations are in agreement with the law of conservation of mass. Now let's see one more example. We have 4 grams of methane reacting with 20 gram of oxygen. The methane is used up completely, but there is some oxygen left over. Given that 20 gram of product was formed, how much oxygen was used up? So the mass at the reactant side is 4 plus 20 is 24 grams. It is given that methane is used up completely, but oxygen is left over. Right? So 20 gram of product was formed. That means how much amount is left over. So out of 20 gram which was available earlier, 16 grams were used and 4 grams will be left over. Why? Because we have got the 20 grams of product out of the total 24 grams available at the reactant site. Next question says 18.02 gram of water is separated by electrolysis. Always remember, when we'll do electrolysis of water, we'll get hydrogen and oxygen. So 18.02 gram of water is separated by electrolysis into its component gases, that are oxygen and hydrogen. If 16 gram of oxygen gas is obtained, what mass of hydrogen must be obtained? Always remember, we have 18.02 gram as a total mass available at the reactant site. Out of this, we have got 16 gram of oxygen and in the product site. The remaining one must be hydrogen, right? This is the reaction. We have got 18.02 as a complete mass. What we have got in the product side is the 16 gram. That means the remaining amount must be hydrogen, which is 2.02 gram. So what we understand till here is that for doing question based on law of conservation of mass, we need to apply simple mathematics. We need to just go for simple addition and subtraction. Now see one more question. 8 grams of methane reacts completely with oxygen and 22 gram of carbon dioxide and 9 gram of H2O is formed. How much oxygen was consumed? We need to go for one simple equation. Mass at the reactant side must be equal to mass at the product side. When we are saying mass, it's the total mass, right? So we have 18 gram of methane reacting with oxygen. Oxygen's amount we don't know, but at the product side we have 22 plus 9 gram, that means total 31 gram of product. So out of 8 gram, the remaining must be the oxygen, right? Another question says silicon dioxide, which is SiO2. Silicon dioxide is made up of elements silicon and oxygen, and it contains 46.7% by mass of silicon. With what mass of oxygen will 10 gram of silicon combine? Now, one thing that we understand from this is that 46.7 by mass is silicon in SiO2. silicon dioxide is SiO2. That means the remaining the remaining percentage is the oxygen, and that is out of 100%. So if we say 100 gram of silicon dioxide contain 46.7 gram of silicon, this is something given to us. That means same 100 gram of silicon dioxide contains 53.3 gram of oxygen, because these two will make 100%. Talking about 10 grams. So the 10 gram of silicon will contain, either you can directly calculate it as 5.33 gram of oxygen, or you can do 10 by 100 multiplied to 53.3. So what we get as the answer is 5.33 gram of oxygen. At the end of the question, you can just box your answer also for a better visibility to the examiner. So students, these were few questions based on the law of conservation of mass. Next law says law of constant or the definite proportion, which says a pure chemical compound containing the same element combined together in a fixed proportion by mass is given by the law of definite proportion. Now this simply means if we have a pure compound obtained from any source, say for example we are taking water from 5 different sources, all these water sample will have its constituent element, not metal, sorry, constituent element in fixed proportion by mass, and this proportion is irrespective of the source of water or irrespective of the method of the preparation. So, talking about water, in water we have hydrogen and oxygen combined in a ratio of 1 is to 8 by mass. Again and again, we are mentioning here mass, we are not talking about the atomic number, we are talking here about the mass, right? So, we have 2H2O, 2H2O formed from 2H2. 1 gram is the mass of one hydrogen. So here we have 4 gram, and oxygen is having atomic mass 16. So we are having here 32 gram. So by simplifying it, we get 1 is to 8 ratio between hydrogen and oxygen when we are forming water, and this ratio will be maintained whenever we are taking water from any ocean, from river, from any stream, from whatever source we are taking water from. The ratio must be 1 is to 8 by mass. This is the law given by law of definite proportion. So this ratio is not going to change. However, this is many times asked in the examination in this way itself. They will ask you to state the law of constant proportion with some example. So you can definitely quote this. Another example we see of ammonia. Ammonia is formed by combining 3 grams of hydrogen, that means 3 atoms of hydrogen combining with 1 atom of nitrogen. So hydrogen has total mass 3 gram. Nitrogen has atomic number 7, atomic mass 14. Interestingly, for hydrogen, atomic number and atomic mass are same. So 3 grams of hydrogen combining with 14 gram of nitrogen for giving ammonia. So in ammonia, whenever hydrogen and nitrogen are combining, the ratio in NH3 between nitrogen and hydrogen will be 14 is to 3 always. And whenever ammonia is formed, no matter in industries, in atmosphere, in from any source, we'll take ammonia, the ratio will be always 3 hydrogen 1 nitrogen, and the ratio by mass will be 14 is to 3. So friends, we will take few more questions from the law of constant proportion in our next lecture. Please stay tuned for it. Thank you.